Dear students, in last class we were knowing the definition of the complex numbers. We will continue our discussion further. Here I just revised the what we studied in last class. Complex numbers are known by letter, denoted by letter Z. It is equals to x plus iy. Here x is equals to real part and y is equals to imaginary part. Here x and y are real numbers, belongs to R means set of real numbers. In this complex number, it is real part and imaginary part. Now, what is I in the complex number? It is I means iota. Iota. Its value is I is equals to square root of -1 and I square is equals to -1. How we got this I square is equal to -1? By squaring this one, we get I square is equals to -1. Now, as usual in addition of real numbers and natural numbers, in complex numbers also we can add and subtract and multiply the complex numbers. Let us take two examples of complex numbers. That is, z1 is equals to x1 plus iy1 and z2 is equals to x2 plus iy2. These are the two complex numbers. We can add them. That is addition. Addition z1 plus z2 is equals to add real parts to real part. That is x1 plus x2, x1 plus x2 plus iy1 plus iy2. You can take I common and write y1 plus y2 in bracket. That is z1 plus z2 is equals to x1 plus x2 plus I, taking I common, y1 plus y2. This is addition of two complex numbers z1 and z2. Similarly, we can subtract complex numbers. Subtract them. That is subtraction z1 minus z2 is equals to x1 minus x2 plus I into y1 minus y2. We can multiply two complex numbers. That is multiplication. Multiplication. Z1 and Z2. Z1 and Z2. That is two complex numbers multiplying. Z1 is x1 plus iy1. Z2 is x2 plus iy2. Multiply the brackets. X into x1 into x2, that is x1 x2 plus I into iy into x2, that is I into y1 x2 plus can multiply this x1 into x2, x1 into iy2. Again you can multiply second term of this complex number to this bracket, that is iy2 iy1 x2 plus I into I square y1 y2. Now we can simplify here. x1 into x2, x1 x2 plus, here I is common in both the terms, you can take outside, I into x1 y2, x1 y2, x1 y2, y1 x2, y1 x2 plus, here I square means minus 1, I square means this is minus 1, I square is minus 1, that is minus into plus, minus y1 y2. Now you can rewrite this as x1 x2 minus y1 y2 plus I into x1 y2 plus y1 x2. This is z1 z2, z1 z2. When we multiplied the complex numbers, we got the answer like this. This is real part and this is imaginary part. This is a real part, this is imaginary part. Now similarly, you can divide the complex numbers. We can divide the complex numbers. That is z1 by z2. z1 by z2. Here z2 should not be 0. z2 is not equals to 0. The division of the complex numbers can be carried out by taking conjugate of the denominator. That is, what is z1? x1 plus iy1 divided by x2 plus iy2. Conjugate of this denominator is x2 minus iy2 divided by x2 minus iy2. Conjugate of this denominator is multiplied divide and multiplied to numerator, divide and multiply by numerator, conjugate of this denominator. So conjugate of this is x2 minus iy2, x2 minus. Now numerator is in the form of x1 minus iy x1 plus iy1 into x2 minus iy, numerator. Denominator, here terms are same with the positive, negative and opposite sign. So it is a plus b, it is a minus b form. A plus b into a minus b is equals to a square minus b square. A square minus b. We know that identity, algebraic identity. So by using that, it is x2 minus x2 square minus I y2 square. Numerator is should be multiplied. Two terms we should multiply by usual multiplication. That is x into x1 into x2. That is x1 x2 x1 plus into minus minus x1 iy2 x1 into iy2 plus iy1 into x2 iy1 into x2 plus into minus minus I into I square, y1 into y2, y1 y2. Now x1 x2 x1 x2 x1 x2, you can take I common, that is, can take I common minus I, or you can rewrite this as this first, that is I into y1 x2 minus x1 y2. Here I square is minus 1, minus into minus plus y1 y2. This is divided by here also I square is minus 1, minus into minus plus, that is x2 square plus y2 square. This is division of z1 term. Next, complex conjugate of a complex number. Here students, conjugate of a complex number is nothing but changing the middle sign of the real sign in between real and imaginary number. That is, z is equals to x plus iy. This is a complex number. Its conjugate is denoted by z bar is equals to x minus iy. This is conjugate. Example, z is equals to 2 plus 3i. Z bar is equals to 2 minus 3. First one. Second one, I minus 1 plus I. Its conjugate z bar is equals to 1 minus I. Just change the middle sign. If it is positive, z bar is negative. If it is negative, third example, z is equals to 2 minus I. Z bar is equals to 2 plus I. These are the conjugate of complex numbers. Next topic, next heading is ordered pair. Ordered pair. Ordered pair means writing two terms in bracket. Terms means here coordinates x and y. Let us take example. Z is equals to 2 plus 3i. It is a complex number. Its real part x is equals to 2 and y is equals to 3. Comparing this with z is equals to x plus iy. X is equals to 2 and y is equals to 3. Writing these two xy terms in bracket 2 comma 3. 2 plus 3i is equals to 2 comma 3. Similarly, 1 plus I is equals to 1 comma 1. 1 minus 2i is equals to 1 comma minus 2. 3 plus I is equals to 3 comma 1. These are called representing complex numbers as an ordered pair. Now we can represent these ordered pair in complex plane x, this is x, this is y, this is y dash, x dash. So first this complex number, that is 1 comma 1, here it is 1 comma 1. If you draw from 0, it is a 0 origin. From here 1, this is also 1, x coordinate is 1, y coordinate is also 1. Let us take this. Here x is 1 and y is minus 2. X is 1, here 1, and y is minus 2. Minus 2 means here minus 1, minus 2. This is the point. This is the origin. This point is P. This is 1 comma minus 2. 1 comma minus 2. Similarly, third one. Here x is 1, y is 1. So x is 3. This is y is here. This is 0. X coordinate y dash, y, x dash. One. Can join this. This is P. Point P. P comma. So representing the complex number, writing the complex number, given complex number in bracket, this is called ordered pair, and representing that ordered pair in complex plane, xy plane, is shown in the diagrams.